And as I mentioned, the training that we have right now is Cisco's Catalyst SD-WAN training. And my name is Abhijit. You can call me AB for these if you want. And I'll be the instructor for this entire training. So before we jump into the course outline, the lab environment details and everything for our day one, right? We'd have a quick introduction session, quick introductory session where I'll introduce about myself and you guys can also introduce about yourself so that we know each other and we establish kind of a two-way communication, which would be fruitful for this long training that we're gonna have, right? Speaking about myself, as I said, my name is Abhijit, and currently I'm acting as the co-founder and CTO, as well as an instructor at PyNet Labs. And I have been delivering corporate trainings, consultancy, right, and doing other services for about 13 years now. And the early days of my career, uh, I was involved into delivering trainings, delivering workshops, delivering faculty development programs at universities and at colleges all across India. And I can say that in those early couple of years, couple of about I would say almost 3 years, I spent majority of my time traveling all across India, in various universities and engineering colleges, delivering workshops on fundamental networkings. And then after that, I changed my vertical and I started delivering trainings around Cisco certification specifically uh, to corporate organizations. Right. So this is where I stopped visiting colleges and universities as a regular, I would say, activity. And I started focusing more into serious networking, more into uh, getting involved into the depth of networking, the depth of network infrastructure, right? And I started delivering trainings around the associate as well as the professional level certifications. And later on, uh, I guess around 2014 or 2015-ish, I got introduced to a concept called SDN, right? Which is very core and important concept in automation, core and important concept in SD-WAN, as well as the other solutions that are there, including ACI, SD access, and so on. So earlier, back in 2014 or so, there were a couple of solutions which were getting popular, right? We had, I guess, Epic EM, then we had Epic DC, and we had IWAN, right? IWAN or Smart WAN, whatever you call it, Intelligent WAN. And later on, the Epic EM got rebranded to SD Access. The Epic DC got rebranded to ACI, and Intelligent WAN got rebranded to SD-WAN. And these solutions specifically focuses on managing a specific type of infrastructure. Okay. So the SD access allows you to manage the campus fabric, right? The ACI allows you to manage the Nexus 9K switches. The SD-WAN allows you to manage WAN edge devices. So whenever it comes down to looking up for a solution which allows you to centrally manage the entire set of managed devices, the no matter what the scale of your configuration is. If you have a medium scale infrastructure, large scale infrastructure, or very large scale infrastructure, you would be able to manage all your manages, all your branches of your organization from a centralized point of touch, right? And that is, I would say, the focus of all or most of the SDN solutions that exist in the market. And it's just not Cisco, right? There are other vendors also. You have Citrix SD-WAN, you have FortiGate SD-WAN, you have Versa SD-WAN. You have so many solutions which are available in the market that talks about SD-WAN specifically. So I got introduced with all these solutions back in 2014 or early 2015. And ever since then, I have been delivering trainings and consultancies around this. But this is not the only thing which I have done, right? I mean, uh, I also got introduced to automation in around 2016 or early 2017. And since then, I've grabbed my DevNet Associate certifications, DevNet Professional certification. In 2023, I got my DevNet Expert certification, CCIE DevNet. So I've been contributing majority of my time into delivering trainings and other services around network automation space as well, core network automation space as well. And recently at PyNet Labs, we have started delivering trainings around AI space, right? AI for network engineers, Gen AI for network engineers, and all that. So, yeah, delivering trainings and I would say sharing knowledge has been my primary passion for about 13 years now, and I'm still fully charged to be able to do so for the upcoming years with the help of PyNet Labs. And that's about my professional experience. If I personally speak about myself, then I belong from a state of Maharashtra in India. But I've been living in Delhi for about 11 to 12 years now. Yeah. And yeah, that's about myself. Now let's try and understand what exactly is going to be the course outline, right? How we'd be doing uh, the lab activities and the other stuff that's involved with this training. So when you look at the course outline PDF, which, but I'll give you a glimpse on what exactly are the major highlights that we're going to focus on. And the very first thing that we're going to talk about will be introduction to software defined networking. Because knowing software defined networking is very important. Since all these solutions, as I just mentioned, right, ACI, SD access, SD-WAN, in the introduction also, most of you guys introduced that you guys work on ACI, you guys work on an existing SD-WAN deployment. So all of these solutions actually uses the architecture of SDN, which is software defined networking. So SD-WAN, ACI, and all that is an SDN based solution. If you do not know and if you do not understand the nitty-gritties of SDN and its architecture, right, what the SD-WAN solution is completely based out of, it will be difficult for you to troubleshoot the pain points, to know the motive for the organization to deploy SD-WAN, right? So we need to carefully understand what is SDN. What kind of challenges do we have in network deployments if we do not have SDN? What kind of benefits SDN brings on the table, right? And what how SD-WAN consumes SDN's architecture, right, for its capabilities. So we're going to talk about that. After we understand the SDN, then we jump to the core topics and we try and understand the fundamentals of SD-WAN, right? This is where we try and understand what are the benefits that SD-WAN as the solution gives you. And once we break it down, then we jump to the components and architecture of Catalyst SD-WAN, right? This is where we try and learn about the Cisco's Catalyst SD-WAN and try and understand what all are the components that are involved in the solution. What's the architecture of the SD-WAN solution, right? And later on, we jump to the control plane operations as well as data plane operations. Okay. So we understand with the concept of or with the role of vManager, vBond, vSmart, right, and managers, or in the latest rebranding, we call it as manager, controller, and validator, and manage devices. We try and understand what each of this component really plays its role into the fabric. What all are the control plane elements? What all are the data plane elements? We try and break it down. We try and understand how, with the help of the control plane and data plane automation, how these managed devices in the SD-WAN solution achieve their onboarding, achieve their route exchange mechanisms, achieve their uh, data forwarding, right, in a fully automatic way. If you guys know or if you guys have heard about, then the new branches, or you can completely automate the onboarding of new branches in your SD-WAN deployment, right? So it saves a lot of money, it saves a lot of man hours. How exactly does this solution do that? That is something which we're going to learn about, right, in the control plane and data plane operations section. And the very first five topics, right, that we're talking about, these are the most important topics that we have. So all of this is gonna be theory only. And we will be talking about these in probably maximum 3 to 4 classes. Okay. But if you pay careful attention on these first 3 to 4 classes, right, then you understand half of the SD-WAN solution. If you pay less attention in these initial classes, right, then understanding the implementational part of it when we get started with the lab deployment, that may become more difficult for you to grasp. And maybe later on you would lose interest. You would be a silent attendee in the training session, right? And you would not really be able to make the most out of this particular training. So I would encourage you and I would request you to emphasize more uh, on the initial classes, okay, on the initial sessions, so that you understand the nitty-gritties of the solution, and then later on you won't really get stuck understanding the lab deployments and performing all the lab activities that we have planned, right? So understanding these five topics is very, very important for us. And then we get started with the next set of topics. That is where we're gonna set up the controller site, right? And this is where we're gonna set up the vManager, right? vBond and vSmart. The very first thing, as well as a certificate authority. So a CA server. And setting this entire fabric is very important. Okay. In newer SD-WAN, we call it as manager, validator, and controller. So yeah, that's the same thing that we're gonna learn. After we set up the controller fabric from scratch, right? Then we jump to onboarding, right? WAN edge devices. Or you can also call them as branches. So we will onboard the WAN edge devices using the mechanism, right? Using the automated mechanism that's there. After we onboard these particular devices, then our focus is towards establishing the site to site communication between the branches. Okay, between the branches. So when we have multiple branches, we would need to set up the communication between the branches, that too using the overlay, that too using the automated tunnels that these branches are going to form. And post that, once that is done, then we focus towards establishing site to internet communication from the branches. This is exactly where we're going to talk about a concept called direct internet access, or you call it as DIA, in which there are a couple of ways of achieving DIA, right? One is local internet breakout, the other one is central internet breakout. We talk about both of these methods. How do we really uh, send traffic from one branch towards the internet? So when the traffic needs to be sent from one branch to another branch, it is sent using the tunnel that has been formed between the two branches. But when it comes to sending traffic from one branch to the remote, I mean to the remote destination, let's say YouTube or Google or Instagram or whatever whatsoever the destination would be, right? That communication is not going to happen in the overlay. That communication is not going to happen with tunnels. That is pure underlay communication. So the vantage should be capable enough of identifying traffic that is not intended to be sent to the remote destination, to the remote branches, as well as it should also have netting capabilities, right? If it is supposed to have it, so that the traffic can actually travel outside your local network. So implementing it can be done by using local internet breakout and central internet breakout. What's that? How to use that? That's all going to come up later. After this is where we start manipulating your traffic. Okay. This is where we start to uh, get familiar with policies and all that stuff. So we try to manipulate the LAN as well as WAN traffic using SD-WAN policies. Okay. Using SD-WAN policies. Again, there are a couple of types of policies. One is uh, centralized policies, the other one is localized policies. So we talk about both of them. One can be configured on Vantage, the other can be configured on the controller. So on which device we configure which policies, right? And what all are different use cases for these policies. That's something we're gonna talk about. Right. I forgot to add one more point over here. Okay. That when we onboard these managers, then should highlight that we also talk about managing the WAN edge devices using CLI as well as using templates. Because vManager introduced something called templates for managing the configuration on these devices. So we talk about how to manage that. And after all these topics, what we discuss is implementing high availability. Okay, implementing high availability in SD-WAN. So how do you implement high availability for controllers, right? What if you just have one controller or one vBond or one vManager, right? What can go wrong? And if you do not want anything to go wrong, how do you set up high availability for the controller side? As well as how do you set up high availability for the branches? That if at a specific branch you just have one vantage as the entry and exit point, and if that particular vantage goes down, then what? And if you do not want that, how do you set up high availability? How do you set up redundancy in such case? This is also something we talk about, right? And lastly, we're gonna discuss about the monitoring. I mean, this is a topic that actually goes on and on throughout the training. So it's monitoring, maintaining, and troubleshooting the SD-WAN, which is a continuous topic for the entire, I would say, training. Okay. So we talk about that on and off. And all of these topics, they are gonna be like theory plus lab. Majority of them, not majority, I would say all of them, they have lab activities associated with it, right? And it's me who demonstrate the lab. It's you who does the lab and then follows that lab activity in the lab that will be assigned to you guys. So this is kind of the overall outline that we will be following. Okay, for the next, I guess about a month, right? We're gonna have about 16 classes, 16 to 17 classes for this training. And in each class we would be spending a good amount of time around these topics. And as all of you might be aware about, you guys are entitled for the lab access, which is gonna be hosted in our data center. So every participant receives a lab access, and each lab access includes one. It's gonna have a Windows jump host, okay, which is like a PC, and that particular jump host is connected outside towards the internet from our data center, and you as a student are gonna access that from your machine. Let me, yeah, this is better. Yeah. So it's like you sit on your you kind of take access of your machine and you visit our portal called https://lab.pynetlab.com. You open this portal in your computer and it is gonna prompt you for the credentials. So you put up your username, you put up your password there, and you can actually log in into the window. So as soon as you put up the credentials, you will be connected to the assigned jump host, assigned Windows machine. And then we also have another machine which is considered to be as EVE-NG network simulator. I'm sure all of you being network engineers must have used this particular tool at least once in your life because this is a great tool available in the world which lets you simulate network devices, network operating systems very easily. So both of these, the Windows machine and the Eve, they are bridged together. They're connected together in our data center. So you cannot access the EVE-NG directly from outside. No. You have to first of all connect to the jump host, and from the jump host, you will be able to access the EVE-NG. And it is the EVE-NG in which we will have our SD-WAN topology. Okay. And how does that topology really look like? So in the topology, we have a controller site. Okay. In that controller site, you would have your like your machine. Like let's say this is student, or rather I would say jump host, the Windows machine. And that particular Windows machine actually accesses the vManager. Then I may have vBond, I may have vSmart, right? And I would also have a CA server, a certificate authority server. And all of this gets connected to a management switch, not a management switch, but a switch that can be connected to the outside world. And then the jump host accesses the vManager from an out of band management interface, okay, to access the GUI. So this kind of becomes our controller site. And then the controller site gets connected to a couple of transport. One I consider as commodity internet circuit, the other I consider as MPLS circuit, like a private circuit. And then we have few branches, right? I will have a branch where I think, yeah, there, where we're gonna have like a VH one, then I'll have a VH number two. Each of this VH is gonna be connected to each of the transport that you have, giving you link redundancy for the site as well as device redundancy for the site. And for security and all, we will also have a firewall there connected, and they all are gonna be connected to your local switch like this, right? And maybe you can have your LAN infrastructure over here. So this becomes one site for you, right? Likewise, we will have more sites. I will have a site over here, okay, where I have my Vantage number 3 connected to both the transport as well as my LAN connected to VS3. Similarly, I may have another site over here right? Where we have VH number 4 connected to the LAN, and then again, same thing, both of the connections going there. And then we may have one more site over here where we have VH number 5 as well as VH number 6. Now, in this case, I'm going to connect the Vanish 5 to the INET and Vanish 6 to the MPLS, and then have kind of a LAN there. Okay. And then we will create a connection between VH5 and VH6 for simulating high availability, right? So you can see this topology covers everything. You have the advantages, or you have one site where you have full-fledged high availability. You have devices high availability as well as link high availability. So there's no chance that this particular site will ever be down unless some calamity happens. Then we have a couple of sites where you have, I think, the link redundancy, but you do not have device redundancy. So if this device goes down, then this site becomes unreachable. If this device goes down, then the site becomes unreachable. Then we have a combination of site where the Vanish 5 is only connected to INET and the Vanish 6 is only connected to MPLS. So if let's say this link goes down, right, and after that this link goes down, then the traffic should go via this link like this. So how to implement that? That is something which we're going to talk about using a concept called T-log extension, right? And maybe we'll have another small site where we do not have any type of redundancy. So maybe VH7 there with its LAN router and only connected to INET. So we neither have any link redundancy nor we have any device redundancy in that case, right? So that's kind of the type of topology we will be creating. Okay. And we're going to create this entire topology from scratch. There is no pre-configuration that will be loaded to handhold you, right? All the lab activities are gonna be from scratch. So we set up the entire fabric from scratch. So you understand how do we really deploy it. Okay, what all are the considerations that you should do while deploying it? What all are the configurational aspects, design aspects, right? Migration aspects that you should take care of. It is possible that not all of you or not all of your organizations are gonna procure a new SD-WAN hardware, right? Many of your organizations are gonna just simply migrate the existing SD-WAN deployment to the SD existing non-SD-WAN deployment to the SD-WAN deployment. So we're going to talk about that. Each lab activity that I do in the class in the session, it is followed using the lab activity guide that you guys also will be receiving. So whenever I'm done delivering the training session, right, we usually have about if you look at the schedule of the session, then I guess we're gonna have classes that will run from Monday to Thursday usually. Okay, and the timings are about 8:30 p.m. Indian Standard Time. Okay, we have dedicated sessions for about 1.5 to 2 hours every class, and then you can, if you choose, you can do the lab activity maybe for 30 minutes or so. If you want to stay in the class and do the activity, you're free to do that. Or if you want to highlight any problem that you're facing in the lab activity, you can do that. Or if you have any doubts, we can have a doubt difficulty session, right? And then we wrap up the day, right? It's possible that nobody has questions. We're done talking for the day and then we wrap it up maybe in 1.5 or 2 hours. That's also possible because we keep the flow of the sessions in an agenda wise manner. And About the number of sessions, also we're pretty flexible. It's not hard coded, or it's not strict rule that we will only have 16 classes, right? That might, even sometimes that might go to 20 classes as well. But the lab access is 24/7. So you are entitled to receive lab access, which is gonna be available 24/7 for this entire training duration. So whenever I'm done delivering a session, done delivering a lab activity, then after the class, I upload the lab activity guide for the activity that I have demonstrated in the class in the Telegram group. And you can download that lab activity guide, you can open up your lab, and you can perform that lab activity. Okay, and you can revise as many times as you want. You can just undo that config, redo the config, right? How so many, howsoever you want to do that, or whatsoever number of times you want to revise that, you're completely free to do that. And if you face any difficulty, any technical challenge, like your lab is not working, your lab is working, but what you're trying to implement is not working, so Telegram is your savior. So, yeah, that's something. These are some of the initial, I would say, uh, instructions, notifications that I wanted to have with you. Awesome. I think we're good then. So, yeah, that is exactly what we wanted to talk about on our day one. We keep it short on day one, just the introductory sessions. All right. Thank you, guys, then. And yesterday, we discussed about the overall content outline, right? How the lab infrastructure is going to look like, how the class flow really looks like, right? That is exactly what we discussed on our day one, since it was an introductory. In today's session, we're gonna pick up the topic called Introduction to SDN. So let's get started with Introduction to SDN. And all of you must be aware that SDN means software defined networking, right? SDN means software defined networking. And in order to understand SDN, first of all, you have to understand how does traditional network function. And this is kind of a common topic that we usually cover in most of our trainings, because most of our trainings are focused around SDN solution, around automation and all, right? So this is very crucial to understand how traditional networks function. Then only if you understand traditional network and the limitations of it, this is when you start understanding about what benefits SD-WAN bring on the table. So in traditional networking, you have lots of devices, right? You have routers, you have switches, you have firewalls, you have load balancers, you have IDS, you have IPS, you have access points, you have WLCs. There are so many types of network devices, network equipments that we work with. And each of these network equipment is manufactured by an organization, right? Be it Cisco, be it Juniper, be it Palo Alto, Checkpoint, right? Sienna, F5, Huawei, Aruba. They can be any of these organizations. And every organization provides one or the other way to manage the network infrastructure, to manage the device. For example, if you have a router like this, then how do you manage that router? You actually take a management PC like this, and then on that management PC, you might be having a utility like Putty, and you connect that particular device by using a console cable, right, on a console port. And then what you do is, as soon as you connect with that device, you start sending CLI commands. This is how you actually manage that device. And not just locally, right? Even if you do not connect with that device using CLI command, you can also expose that particular device on a network. So maybe you connected with your ISP, and there can be a specific user, okay, which can be considered as a remote user. And that remote user may use a utility like Putty and can make the connection possible over remote management sessions like SSH or like Telnet or by using even HTTP nowadays. There, that remote user can send CLI commands to the device and can manage that router, right? Both of these ways are available. If I give you a backstory, a few decades ago, a couple of decades ago, organizations would go to the network uh, vendor, and then they would procure devices that are manufactured by a single vendor. If they want to build their network infrastructure, they would purchase everything from Cisco or Juniper or Palo Alto or others. And then they would hire people who knows how to manage these devices, right? That is where they will start looking for Cisco's network engineers, Juniper's network engineers, and so on. So in this case, after a few years, organizations started implementing multi-vendor deployments, which means they stopped procuring everything from one vendor and they started looking for value. They started looking for value for money products and value for money solutions. This is when they started procuring, for example, devices, routers from Cisco and firewalls from Checkpoint and load balancers from F5 and so on. And in order to manage that, they would also need people with those skills. So this is where a shift in the engineers started up, where engineers started to upgrade themselves with skills of being able to manage different or multiple types of devices. So a network engineer would be skilled, right, when he or she learns how to manage devices of Cisco, but not just Cisco, right? He or she should be capable of managing other vendors' devices also. That's when he or she would be believed to be a skilled network engineer. And organizations would value such engineers. But it is not easy, right? From the employee perspective, it is difficult to understand or to I would say learn about managing devices of different vendors because of different syntaxing requirements, because of different ways how configuration is implemented, because of uh, different ways of how these devices are maintained and managed. So it started becoming difficult. And this is when the industry saw that CLI cannot be the only way of how devices can be managed. And that's where GUI came up. Like we saw that there are very popular devices, for example, Cisco's ASA, right? Adaptive Security Appliance. So you can connect with that adaptive security appliance in two ways. You use the same management PC, right? And on the same management PC, if you want to do the CLI management as well as you want to do the GUI management, you can use dedicated tools. If you want to manage that ASA using CLI, you use Putty or Super Putty or M Putty, whatever it is. And if you want to do the GUI management, you use a utility called ASDM, Application Security Device Manager. Using that, even if you do not know any single command of your ASA, still you would be able to manage these devices. Make sense? And that was very popular. That became very popular. And for this, for because of this capability, the organizations or the engineers learned to manage different type of firewalls because conceptual understanding is same. It's just the implementational difference that they need to be worried about, right? And understanding implementational differences has become easy because of the introduction of GUIs, right? So from the management perspective, they ease down the things. But what from the devices perspective? What about devices? What about the way how traffic is forwarded? What about the way how devices are managed, right? That was still same. So when you look at a traditional network, right? If you look at a traditional network, how does a traditional network look like? You may have, let's say, a router one, and that router one has a switch connected to it, and let's say a few endpoints. And this is maybe a network called 192.168.1.0/24. And let's say we have another network called R2 connected to a switch and again a few endpoints, and that uses a subnet of like 192.168.2.0/24. And you connect both of these together by using a bridge network called 192.168.3.0/24. And let's suppose that you have implemented static routing, right, in this entire scenario. So currently, if this particular endpoint wants to communicate with this endpoint, your traffic goes first of all to router one. Router one performs some lookup into the routing table, and then it figures out that the traffic needs to be sent on this cable. And then router two receives it and performs the routing table lookup, and then forwards the traffic down below to the original destination. And that's exactly how the reverse traffic will also be forwarded. So we think that this is how traditional network works. But internally, there are multiple components which actually makes this happen. A router is not only responsible to forward the traffic from one interface to other interface. No, a router has a lot of other jobs also. Okay, it has to perform uh, the cyclic redundancy check to ensure the data is not tempered. It has to decrease the time to live value in the header, right? Every time a packet crosses a hop, it has to change the MAC addresses, right, of the device every time the packet crosses a hop or the frame changes. It has to uh, send hello messages on all of its interfaces if routing protocols are enabled. It has to maintain the routing table, right? It has to send routing updates. It has to receive routing updates. It has to calculate the best paths. All of these operations are done parallelly in a router. And similarly in other devices, in switches, in firewall, right, in load balancers, every single network device has a lot of operations that it needs to do. And all these operations can be done with three simple planes. Okay. The network devices, we should say that the network devices are capable to perform all the operations because of three planes. Which are these three planes? All of you might have heard about. One is the management plane, second one is control plane, and third one is data plane. And every single device, be it router, be it switch, be it firewall, all of these devices, they do have these planes. So management plane is nothing but the CLI or GUI interfacing system. Whenever you consume any device's CLI or GUI to interact with the device, you are using nothing but the management plane of that box. Whenever you are uh, doing any configuration, right? And as soon as your device kind of applies that configuration on its operating system, it is the control plane who is doing it. You see, whenever you enable OSPF on your router, all your interfaces will start sending hello messages quickly. It is because that the processor have started the OSPF operations, OSPF feature, right, in its system. So whenever you provide your intent, the management plane gives that intent to the control plane. And then the control plane does all the decisions because it is handling the central processing unit, the CPU. And then once the decisions are taken, then the decisions are also forwarded to the data plane so that the traffic forwarding can be done according to the decisions that have been made. So data plane is where your line cards are situated. And like I said, every single device has these three planes. You have the management plane, the control plane, and the data plane. Think of it this way, that if you look at an architecture of any particular device, it looks something like this. Easy to understand. Okay, let's say you have the management plane. So this is kind of the CLI or GUI. Then you have the control plane. Mhm. In which, let's say, you have multiple protocols. Okay, let's say you have OSPF running, you have EIGRP running, you have static routing running, right? What does OSPF do? It creates neighbor table. It creates link state database table. What does EIGRP do? It creates neighbor table. It creates topology table. And then it does all the calculation, and then it puts the decisions in something called routing information base, which is what we know as RIB. So the best routes are gonna insert into the routing information base, right? Even static routing or static routing protocol is gonna give its route to the RIB, and it's gonna work in conjunction with ARP to find out where to forward the traffic. And that decision is gonna be given, which is where you have forwarding information base. Okay, or we call it as fib, and that's where the info. So this is your management plane, that's your control plane, and that's your data plane. And a router or any network device is made up of this simple architecture. Of course, there are nitty-gritties and other things which differs in every device, but this is kind of an overall architecture of how the device looks like. And that is how traditional network functions. Okay, when we look from a device perspective. But what we are more concerned about is to understand what are the limitations in this way of functioning, right? So when we look at limitations in traditional network, because that's what we are required to understand. So I'll give you an example which I usually give in most of my trainings to help you guys understand how traditional network is limited. Let's say you have an ISP, a classic example, and that ISP has provided connectivity in several of your offices, in several of your branches. You have this branch over here. Let's say it is headquarter, and in that branch you have a server. Okay, this is a server, and in which you have multiple virtual machines. You have virtual machine number one, you have virtual machine number two, virtual machine number three, and these are business applications of your organization. Can be anything: ERP system, CRM system, whatever. And the ISP provides connectivity, right, to the edge routers. Maybe you have firewalls internally over there. Maybe you have layer 3 switches. Maybe you have layer 2 switches. And then you connect it. Now, maybe you also have mesh fabric implement. And the ISP also provides connectivity to a couple of other offices, right? Like that. And you have employees sitting over there, employees sitting over there, and these employees wants to access these softwares. So to make that happen, what kind of configuration you would really deploy over here? So you would have lots of things running, right? You would probably configure BGP, you would configure IPsec, you would configure OSPF internally, you would configure network address translation, you would configure HSRP, you would configure spine tree protocol, VTP, right? Inter VLAN routing, VLANs, and so many things. IP addressing, subnetting, blah, blah, blah. And you would make that device function. You would make that environment function. You would make that application available for the people sitting in other branches. And let's assume that it's all working fine. And now the organization has one requirement, that on the same server, they have installed 3 new virtual machines. And we consider these as new business applications. Okay, new applications. And now people who are sitting in these offices, they want to access these new applications. Now what? So the virtualization guy will just come and do his or her job in maybe a couple of hours. But for us as network engineers to incorporate that new applications and make it available for the other people, it can take hours or days for us, because you'll have to access every device one by one. You will have to make changes on routers and firewalls and switches and all that, right? You will have to access the device and do the BGP manipulation, IPsec manipulation, OSPF manipulation, and whatnot. Why do you need to take access of every single device? Because each of this device has its own management plane, has its own control plane, has its own data plane. It's over there, it's 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 there. Right? That's why the admin will contact to every device's management plane, access the CLI or GUI, and do the change. And this is called limitation, because it is slow, it is manual, and it is error prone. That is big, big, big limitation in today's network environment, because we are growing with the complexity of the network infrastructure, and we are, uh, I would say, not performing very well in terms of the amount of resources available to manage that network infrastructure. So complexity is growing and resources decreasing. Okay. So we're falling short of the resources that we have for managing the complex network infrastructure. And this is where SDN comes to picture. So when you look at SDN, how does SDN's architecture differ? What does SDN do then? SDN actually proposes a very simple shift in the architecture where the admin is sitting here, let's say. Okay, this is your admin, and that admin connects to something called SDN controller. The controller over the ISP connects to the infrastructure which you have. This is the change. Earlier, there is no controller. There was no control. The admin directly speaks to infrastructure. But now the admin cannot go directly to infrastructure. The admin has to go to the controller. The controller will go to the infrastructure. So in the infrastructure case, let's say you have a branch over here, another branch over here, another branch over here, another branch over here. And this is the edge router of the branch. This is another edge. This is another edge. This is another edge. And what will you do? You will just go to the controller and say, hey, controller, I want to do some config changes. Controllers will say, okay, what changes? I will say, I want to configure OSPF on few of my WAN edge routers. Controllers will say, okay, which WAN edge routers? I'll say these. Controller will say, okay, tell me the OSPF changes. I'll say, I want to advertise these 4 new networks on each of these devices. Controller will say, okay, I'll prepare the config. Admin says, okay, let's show me the config. Controller says, here's the config which will be deployed on the devices. Admin says, okay, push it on router 1, 2, and 4. And this is where the controller validates the config and pushes it to the necessary devices in one go. But while this communication was happening, right, until the administrator said push, there was no configuration that was pushed to the device. And this is also called intent-based networking because your intent is first of all exchanged with the controller. The controller prepares the configuration according to the intent that has been specified by the administrator. The controller also validates the configuration, right, before pushing it. And the controller finally pushes the config to the network infrastructure. So in this case, what happens to the data, to the WAN edge devices that you have? Well, these WAN edge devices now will only and only retain the data plane. Okay. Earlier they had control plane, but now they will only retain data plane. And it is the controller where you would say control plane sits over here. In SDN architecture, what we are doing is we are actually interacting with a single management plane. We are stating our intent to the controller, and then that management plane tells the control plane which is available within the controller. There might be a separate entity, or it might be part of a similar like component that's available in the solution, and the control plane is going to interact with the data plane of every device. Okay, so here's a separate data plane, 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 right? And it differs actually. I mean, we're talking about SDN right now. We haven't started discussing SD-WAN yet. We're just talking about SDN as an architecture. And the entire uh, Cisco's portfolio, or I would say other vendors, Whatever solutions nowadays are coming up in the industry, they are actually following the same architecture. If you look at some of the popular solutions that Cisco is selling, which are considered to be as SDN solutions, they include SD-WAN, they include ACI, right? It includes SD access, and each of them uh, is focused towards managing a specific type of devices. SD-WAN manages all the WAN edge routers, right? The ACI manages all the Nexus 9K switches, right? So in this particular case, you can say that the all of these uses the SDN architecture where the controller differs. For SD-WAN, the main controller that we have is vManager. The for ACI, the main controller that we have is Epic. For SD access, the main controller is DNAC, or nowadays it has been rebranded to Catalyst Center, right? So this controller actually changes based on what solution you're using, and so does the devices change, right? Depending on what solution you are using, the type of infrastructure you are managing, and the type of controller you're using to manage that infrastructure changes. But the architecture remains same, which is centralization of your management plane and of your control plane elements. Now, within the SDN, there are a couple of flavors. Some, one we understand as pure SDN, and then there is something called hybrid SDN or partial SDN. What is pure SDN? Pure SDN means that the devices which you are managing, the infrastructure which you are managing, they will not have any capabilities to do the local management. Which means once your managers, for example, okay, if you are managing them, if they start to get managed by the controller, then the admin cannot log into these devices and make any changes in their CLI. No. Then in that case, all the changes must be done via the controller to those devices. This is called as pure SDN. And hybrid SDN means you have a management plane, but the control plane is available in the controller as well as devices. So the admin can still log in and do some changes without doing it via controller. And the admin also has a choice to do it via the controller to the devices. This is called as hybrid SDN. So for the firewalls, what we have nowadays is called FMC. If you have worked with it. So if you have, let's say, FTD devices, FTD over here, FTD over here, FTD over here, then this is where we have FMC. So the Firepower Management Center manages multiple FTDs, manages multiple next generation firewalls. Okay. Now, so I think we're good with SDN. We're good understanding what SDN is. And then we're going to jump to the SD-WAN's understanding now what SD-WAN as a solution is. Now we're going to talk about introduction to SD-WAN. Now, as the name suggests, SD-WAN stands for Software Defined Wide Area Network. And what it does is it actually automates how the branches are onboarded, right? Managed, or rather, I should say onboarded, provisioned, okay, managed, and troubleshoot it. SD-WAN or implementing SD-WAN in your environment is a way to automate onboarding your branches, provisioning your branches, managing your branches, and troubleshooting your branches. If you look at some of the benefits that SD-WAN brings on the table, benefits of SD-WAN, then one, it does automated WAN edge onboarding. What I mean by that, earlier or without SD-WAN, if you want to onboard a new site, then the organization will actually uh, send its net technician to that particular site, right? And then the onboarding of the manage will actually happen. But before understanding this, how you are actually saving a lot of money in this, right? How you are actually uh, able to achieve automation into SD-WAN. One of the benefit that you see, as I said, is automated manage onboarding. Okay, so you no longer need to send your engineers onto the remote site, then connect the devices to the ISP links, then configure that devices, right? Then make these devices communicate with the hub side or with your branches. If you have 500 branches and now the 500 first or 500 or after deploying 499 sites, you are deploying the 500th site, and you need that 500 site to be communicating with the other 499 sites. So you can imagine the amount of configuration that you will need to do on that device. And if you manually need to do that, then it's going to take days to weeks to even check whether the connection with each site is working fine or not. That's why onboarding a site takes a lot of time. And if you automate that, then it saves a lot of time, right? So the organization can start the business as soon as possible. Okay. How it does that technically, we're going to talk about that. Currently, I'm just introducing you with this in descriptive manner that what exactly are the benefits. Second, you can bring down costs, bring down transport costs. Instead of saying transport cost, I should say ISP costs. Okay. How? So here you need to understand that whenever there are two sites that want to communicate together, okay, let's say you have site number one and you have, like, let's say your vantage number one here, and you have another site and you have vantage number two there. Okay, this is, let's say, Bangalore, and this is, let's say, Pune, and both of these are connected to their ISPs. Now whenever you use ISPs in between, the ISPs also have their own infrastructure. So assume that this is an ISP circuit. Okay. Now every ISP is going to have provider edge devices. So let's say this is provider edge one and this is provider edge two device. The provider edge devices are going to connect, okay, between your WAN edge and the provider edge device. So there will be connections laid over. And then the provider will use its own internal core architecture, like there are going to be a lot of normal provider core routers like this. Okay. And you're going to connect in this way. This is how usually the ISP infrastructure looks like. Because ISP ensures high availability between your branches. So if your traffic is going from one point to the other point, it can go via this way, it can go via this way, it can go via any way in the middle or any this way, right? There is no chance, or there is very minimal chance that your traffic will not go from one point to the other point. And this is exactly why you are paying money to the ISP. So your managers or your branches can be connected in three different ways. Okay. What are the ways to connect your branches? One is you can have private link, private circuit. Second, you can have a circuit like MPLS. And third, you can have a circuit like commodity internet circuit. Okay, or rather I should call it as leased line. Okay, better I call it commodity circuit. And then there are few factors that we need to consider. Okay, what kind of factors? Do you get security? Do you get uh, reliability? And is it cost effective? So affordability, right? These are the factors you should consider. Whenever you're gonna connect these branches together, if you lay your private link from one point to the other point, you actually set up your own fiber or dark fiber cable. Will you be able to achieve security? Yes. So high security because you're not sharing that transport with anyone. Will you get reliability? Of course, high. You will have high reliability because you are the only one who is sending traffic on that particular link. And what about affordability? Lowest. It is going to cost you so much money, right? That it will become hard for you. You will start thinking, do I really need this much of security, this much of reliability? Although still people or organizations, they use it. For example, government defense organizations, they lay their own fiber cable because security becomes the primary concern and cost becomes the secondary concern. And you are not at all looking to save money at that particular case because national security comes to picture, right? So there are use cases and there are organizations who lay their private link from one point to the other point and never share the transport with any other party. Then there is MPLS. In MPLS, you get high security, or not, I should say you get medium security. Okay. You get high reliability and you get medium affordability. Correct? Why? Because this is where you start using public transport. So because you don't want to invest that much of money and set up your own point to point link, then there are organizations called ISPs, Internet Service Providers, who have invested that money and they have set up this entire infrastructure nationwide, right? To set up gateways, to set up provider routers, to set up the core infrastructure, to lay down the fiber cables in the entire country and provide reachability. And how do they make money after making this much of investment? They let other people use their infrastructure, and in exchange of that, they take money from them, rent from them, right? Service fees from them. So think of this as the customer one, right? Customer one's Bangalore office, customer one's Pune office. Customer one say, hey, I cannot set up my own link. Can you let me use your infrastructure? Provider says, please welcome. Give me this much of money. I will let you use it. WAN says, okay, here's the money. And then the WAN actually connects its WAN router with the provider's edge router. And then it starts forwarding traffic using the public link. Now, how do you secure it? Because there is another customer. So you have in Bangalore only, you have another WAN edge. This is customer two. This is customer one. And that particular customer is also connected to the same provider edge. Here also you have VH2, but it is customer two and connected to the same provider, right? So this same infrastructure is being used by customer one as well as customer two. And while customer one is sending the traffic, customer two is also sending the traffic. So it's using common transport. And what you want? Security. Customer two should not be able to see the traffic that I am sending, being customer one. So then the uh, ISPs actually set up virtual tunnels, right, for each customer. So this is customer one tunnel. This is customer two tunnel. It is in the underlay, it is using the same infrastructure, but on the overlay, virtually, nobody will be able to see each other's traffic. Okay. That's when tunnels comes into picture. And when these tunnels comes into picture, you achieve security from provider edge to provider edge. And ISP take money, more money to provide you this much of security. They also use a specialized hardware so that their motive is to forward your traffic from point A to point B as fast as they can. So here, when the traffic is actually traveling over here, it is unencrypted traffic because it is in the private environment. Till here also, it is unencrypted traffic because it is in private environment, and here it is public infrastructure. That is where your traffic gets encrypted by using encryption mechanisms, so that nobody is able to read the traffic when they catch your traffic, when they sniff your traffic, and so on. That's why we say that MPLS provides medium level of security, and it also provides high level of reliability because specialized hardwares are used to forward your traffic from one point to the other point as soon as possible. And when it comes to affordability, it is expensive, right, as compared to commodity circuit. That's why we say that it provides you medium capability. And then when it comes to commodity circuit, then in commodity circuit, you get low security, you get low reliability, but you also get high affordability because these are the cheapest way to get connected between the branches using the public infrastructure. Okay. However, there are ways how you can make this communication secure as well. So you can have it secure. I mean, you can have low security, but it can be configured. I mean, can be secure when configured manually. So what organizations started to do? They started signing up for the commodity circuit where the type of hardware is not that good, the reliability is not that good, there is no security, there is no overlay tunnels that have been set up for your sites. So your traffic is always traveling in the underlay. And in order to make it secure, this is not the infrastructure which you control, but this is the infrastructure which you control. So organizations started setting up the tunnels from CPE to CPE, right? Customer premises to customer premises. So if you don't want to invest the money in ISP infrastructure so that ISP can set up the tunnels for you, then you spend more money in hiring engineers who can set up tunnels between all the branches. So imagine that you have 500 branches and each router needs to connect with, have a tunnel with every other router. Imagine the number of tunnels that that will be formed there. So you don't want your engineers to sit and configure all these tunnels, hundreds of tunnels, right? Then you pay money to the ISP and ISP will take care of that. If you don't want to pay money to ISP, then ask your engineers to set up tunnels with every other branch from every other device. And still you will be able to achieve the same level of security. Although the quality of transport is not going to be same as of MPLS, but at least you can meet the same level of security, right? And that's why we say that commodity internet circuit provide the low level of security, although it can be configured to medium level of security. Make sense? These are different ways of how connections are done. And that's why and the way I'm saying that bring down ISP cost, it is actually achieved because in SD-WAN solution, this CPE to CPE tunnel is completely automated. Your network engineers are not at all required to configure any tunnel with any other branch. Still, as soon as your branch becomes part of the SD-WAN fabric, your branch will form tunnels with every other branch that is there, every other SD-WAN branch that's there automatically. And which saves a lot and lot of time, which saves a lot of money. Okay, that's why we say that it brings down cost. Many people also misconceptualize that SD-WAN is going to replace MPLS. That's not the case at all. Okay, if you think that, it is wrong, because MPLS is not going to be replaced at all because MPLS provides high reliability. Commodity internet circuit with a combination of SD-WAN solution will allow you to achieve the same level of security without doing any manual work, without doing any extra work. But still, in terms of reliability, commodity circuits are behind MPLS's reliability. You cannot match it. So organizations are actually rethinking of how they can save money, and how they are doing it is by only using MPLS circuit when it is needed. For example, when it is about forwarding the latency sensitive data from point A to point B, like voice and video traffic, there you consume MPLS. And when it is delivery sensitive data where latency is not of any concern, then you start using commodity internet circuit. So earlier, where you utilized only MPLS for all sorts of traffic, now you only use it only when it's needed. So you bring down your cost. You do not actually get to replace MPLS. Make sense? Okay. Then the third benefit that SD-WAN brings on the table is automated, or instead of saying automated, I should say centralized fabric management, which means you get one controller and you would be able to see and manage the entire fabric from just single point of touch, like the control, like we're talking about, right, in the SDN architecture, that you just log into the GUI of the controller and you would see the status of all the managers. No matter you have 10 managers or 100 managers or 1,000 managers, you will be able to track which manage is down, which manage is up, on that particular managers, how many tunnels are up, is there any tunnel who's down, right? If I'm supposed to have 50 tunnels on my router one, and if I see 49 tunnel, which is that tunnel which is down, right? What's the performance of my site between my site 1 and site 51, right? How many applications am I using between these sites? What are my top most applications? All of this information is something that you can see directly in the GUI of your controller. So, which provides lots and lots of visibility. And it also helps you and assists you in taking the best decisions for your fabric. Okay. And then another benefit which we can talk about is centralized route exchange. What do we mean by centralized route exchange? It means that earlier, like I said, so if there is any particular route update that, let's say, this particular vantage needs to send, then the route update will be sent to all the other vantages, right? And then every other vantage will actually consume its CPU, its memory to process that route update, to install the route in the routing table and do certain other things. Now, when the number of routes are small, like few thousands, it's fine. But when the number of routes increases, like each device has 10,000 routes in the routing table, right? Then the overhead, something we call as overhead, the amount of compute and memory utilization that the device needs to put in to process a route update, right? That amount of overhead increases, right? So when your vantage is not responsible to forward any route update to any other vantage, right? Then it can focus, or it can utilize all of its compute, RAM, and all that in terms of forwarding the traffic to the remote devices with the best of its capability. So you see performance improvement. And it is only now required to forward the route update to the control plane. It is the control plane. You have a dedicated CPU RAM which is separate from your vantages, which is going to take care of forwarding the route to all the other vantages. It is not this device who's consuming its own compute and memory to forward it to all the other vantages that are there. There is this dedicated resource which is taking care of that. So that also gives you performance increase, performance gain. Okay. So these are the core benefits that SD-WAN as a solution brings on the table. Make sense? Awesome then. So these are the few pointers that we wanted to talk about in this particular session today. That is what we wanted to discuss. Today we talked about a couple of topics. One was the introduction to SDN. Second was fundamentals of SD-WAN, right? In our next session, we'll be talking about the components and architecture of Catalyst SD-WAN. We'll be talking about the control plane operation as well as the data plane operations. Okay. And this is going to be the most important session for us.